Hi, this is Andy Orm of O'Reilly, and I'm talking to Arijit Sengupta, who is a speaker at the upcoming Strata RX conference and also works at BeyondCore, an interesting company in the area of visualization and data. And we talk a lot in the data field about visualizations and how important it is to make the data come alive. But I think BeyondCore is doing something on a totally different level of making the data feed into the visualization. Can you talk about that?
Absolutely. What we are trying to do is let the data speak, but not in cryptic language in a manner that a business user can understand. So if you think about the different types of analysis we do, statistical analysis, through data warehousing, for example, there are various sorts of analysis that happens. And after that, there is a various sort of visualization that happens. Well, can we just tie it all together so that a business user can go to a software and say, tell me about my revenue, or tell me about the patient length of stay, and just have the software do all of the heavy lifting so that they can focus on the business insight rather than all the heavy lifting.
But I wonder if you could describe what a briefing is traditionally and how you're doing briefings.
Absolutely. So in a typical visual analysis situation, what you do is, if you're a business user, you might be able to generate a report yourself, or you might go in and request a report from someone. Then you get the report, you look through it, you ask for a different report, you start comparing them, you start figuring out what's interesting. So it's almost like hunting through a needle in a haystack, and you're the one doing the hunting. What BeyondCore does is, we want to give you the analyst experience. So let's have the software tell you that the most interesting graph was this. But you need to consider when gender is male, because the behavior is different in that case. Let me highlight to you exactly how this diagnosis behavior is different if you're a male as opposed to a female. So we are walking you through the key insights in each graph, as well as the relationships between graphs, because the truly interesting insights actually come in those spaces between the graphs and the relationships between them. And every real world pattern really involves multiple variables. I haven't found a very interesting one variable pattern yet, right? So you have to start getting into what happens when I have a high BMI, I'm male, I have a certain race, I go to a certain hospital, what's my expected outcome? You have to get into multiple variables. Well, that is exactly what an animated briefing is about. How can we show you a series of 4, 5, 6 variable patterns through a series of simple graphs so that a business user can comprehend the insight without having to understand very complex visualizations or statistics?
BeyondCore introspects a file, figures out that there are several fields in there, for example, age, gender, etc., and it deals with numbers and text automatically. It then gives us the option to choose what is the business outcome, which in this case is excess stay. And excess stay is defined as the actual length the patient stayed in the hospital, less the amount Center for Medicare and Medicaid expected them to stay. So we'll just choose that and hit submit for analysis. Now note that the only thing I did was choose the outcome and hit submit for analysis. I didn't provide any hypothesis. I didn't tell it what variables to control for. BeyondCore automatically figures out all of those factors. It looks at thousands of questions, thousands of hypotheses, if you will. It looks at what variables might be affecting, what are the confounding effects for any analysis it's doing, and it automatically figures out what's important and what is not. Once it's done with this, first we'll go to our animated briefing, which will walk us through what exactly is interesting in the data.
Here is our analysis of average excess stay. The first attribute we have chosen to report by is diagnosis, because it explains 5.1% of the disparity in excess stay, the best of any single attribute. Let me highlight the key outliers here. Septicemia, except in labor, 1,800% higher. Rehabilitation care fitting of prostheses, 1,500% lower. Congestive heart failure non-hypertensive, 830% higher than the overall average. But to get the full picture you need to see more. Consider when age is 0 to 25, because the average excess stay behaved differently in this case. Rehabilitation care fitting of prostheses, 9.147 higher than usual.
Note that this is completely being done automatically. The tooltipping, the text you're seeing and hearing, what graphs it is showing, all of that is being done completely automatically. What the software is doing here is highlighting to us that age matters, but only certain age groups. And they matter differently for different diagnoses. And it walking us through those relationships. because most of the interesting insights are actually in between these relationships. Similarly, after doing diagnosis and age, it's now gone in and said, hey, diagnosis and facility matters. So hospital E is behaving differently for different diagnoses compared to other hospitals.
Perhaps based on this hospital video that you made, suggest some ways that data would be taken in and what the software does to find the relationships that it shows people.
Right, so a couple of things are happening there. First is today, customization is a big problem for many organizations. Getting the data loaded and dealt with takes a lot of time. What happens with BeyondCore is we introspect the data. So if it's in a CSV file, it's in a database, it's in a Hadoop repository, it doesn't matter. The software looks at the data and figures out what's the structure of this data. After that, we ask the user just a simple question. What is your business outcome? What's the outcome of this analysis that you care about? And once, in this case, in the video I sent you, the outcome was the excess length of stay. How long did I stay at the hospital? Now, the software now starts looking at millions of variable combinations if the data is sufficient for it. In this case, it was a few thousand combinations. But it can look at millions of variable combinations, trying to figure out, well, what are the key drivers of excess length of stay? When do I end up staying really long, or when do I end up staying really a short period of time? And is there an underlying pattern to it? What are the confounding effects to that pattern, right? Maybe I'm looking at different diagnosis code at different hospital, but what I don't know is one hospital mainly gets really low income people, and maybe that is biasing the information, right? How do I constantly look for those biasing factors and cancel those out? And that's what the software does automatically.
Yes. And it seems like it's in some ways a typical clustering practice done in real time.
So it does use clustering algorithms. It actually uses certain search-oriented algorithms. It's using machine learning. It is also doing a regression analysis, right? Our point is we throw a bunch of different algorithms at it to figure out what's interesting about this data. And then unless you're a statistician and you go into statistician view just for the heck of it, you actually don't have to deal with the machine learning. You don't have to deal with the clustering algorithms. You don't need to understand how we got to the insight. All you need to see is what's the insight and what's the evidence for the insight. Because the software always makes the evidence for the insight very clear. We won't just say this hospital is doing well or this hospital is doing badly. We will show you, hey, this hospital has this mix of Asian Americans as opposed to African Americans as opposed to white people. This is affecting this much of the outcome. This hospital takes in a lot more emergency cases. That's affecting the outcome. And here is the expected outcome because of it, right? We are explaining the predictions, explaining the insights in a manner a business user can understand and hiding all the complexity.
Yes, one of the interesting things I noticed in the video was that you compare hospitals. And you start out by saying there could be some differences, such as in the population or the severity of illness, but then your analysis can account for that and remove those factors and then find out what is still an outlier.
Exactly. When you look at the waterfall graphs, what we're actually doing, in that case, we would have looked at 1,000 drivers, and we only highlighted maybe 10, 20 most interesting drivers. In fact, let me step back. We would have looked at millions of variable combinations to first select those 1,000 drivers. Then we could have visualized up to 1,000 drivers if it was important. But in any specific case, maybe 20 drivers are most interesting. So the software visualizes it, but accounts for every one of those 1,000 drivers that we selected out of the millions of possibilities.
In any data set, you're going to have extreme outcomes. For example, in this case, we find that if you have septicemia, and your payment type was managed care, you had about 10 days excess length of stay. Now that's intriguing, but let's click on this and find out what actually drove this. BeyondCore actually looks at all of the variable combinations, and it finds that septicemia and managed care, that combination actually does have a 4.2 day impact to your expected length of stay, even after we adjust for all other variables. So the software takes into consideration all of the other factors. Did certain other factors like gender being male and ethnicity not being Spanish, how much did that matter? It is considering all of these other effects and then figuring out the net effect of this specific combination is actually still 4 days. This gives us a sense of exactly what's important in the data set.
Are there any special techniques you use to make this work in real time? Because it looked very fast in the video.
Well, one thing is, in this case, we're looking at 75,000 rows of data. But if you look at the McKinsey case that we are presenting at Strata, that was 30 million patient lives. And we were looking at 1 million variable combinations, right? So we actually use a technique very similar to Hadoop, but Hadoop can do multiple clustered information where it's going by the association between the data, the data's, the content of the data, if you will. We are doing something similar where we are going with the mathematical relationships between data, right? So just think of the data world being elevated to a statistics world, and now we are doing something very similar to Hadoop, which allows us to run this on a bunch of commodity hardware. In fact, one of the fun things we can do is we can plug in one extra Mac Mini to the cluster, or any laptop or any PC that you have. We can just plug it into the system and we can speed up the analysis even further.
Okay, what are some of the successes that you can report? What have you done that has benefited the public health area or hospital or something like that?
So this is the part that gets us most excited. So we were working with one of the largest the hospital systems in the US, and we analyzed their data trying to look at patient length of stay. And we found some very interesting patterns, like for tracheostomy, a certain hospital in Chicago was doing much, much better than a certain hospital in Detroit. And we started finding some very intriguing patterns there. So the hospital ended up digging into it, and they found a cluster of hospital-acquired infections in Detroit, right? Mm-hmm. But they hadn't noticed it when you first started because hospital-acquired infections are self-reported. And what is actually far more powerful is to look at the statistics to figure out, hey, is there something strange happening here that cannot be explained by standard variables? Now we should dive in and figure out what's going on, right? It's much more easy for the hospital or the organization to figure out these patterns statistically than through manual review.
And then maybe next time this analysis is run, they'll have collected better data to start with.
Absolutely. In fact, one of the funny things that happens is nobody has clean data, right? And BeyondCore is designed to deal with unclean data. That's what our premise is, that there is no such thing as clean data. So in the same hospital system, when we ran the analysis, we suddenly showed them that 2 of the hospitals in their huge chain were reporting neonatology length of stay in a number of hours, not days. The funny thing was they had never noticed that, even though they had run many, many reports on that, because if you run a report across hospitals, it's not obvious. And nobody really runs reports across neonatology across the various hospitals. So that pattern had never been seen. But just imagine hourly reporting as opposed to daily reporting getting summarized up all the way was definitely affecting the overall reports for these hospitals, right? BeyondCore comes out in a matter of seconds and says, these 2 hospitals for neonatology is behaving very, very differently. You might want to check what's going on.
Mm-hmm. Now, there are, of course, a lot of visualization tools out there, and you would like to describe some of the other available tools and how yours is unique?
Well, the key thing is the whole category of visualization software is a little bit dangerous because visualization softwares show you visual outliers, which are perfect if you're looking at a single variable situation, right? As a human being, we can find visual outliers very easily if I have a simple graph. But imagine I have 2 variables, 3 variables involved. All of a sudden, there is a statistical confounding effect of the other variable. In the video, I have this example of one of the hospitals where septicemia looks like it's the most interesting excess length of stay pattern, but actually that pattern was true of all hospitals. It wasn't specific to that hospital. You needed to statistically adjust away what is the effect of all of the diagnosis so that you're left with the net effect of the hospital. Well, visual analysis can't help you with that. In fact, visual analysis will take you down all the wrong paths, all of the shiny objects, if you will, rather than where the real gold is. So you need to marry statistical analysis with visual analysis if you're going to have true impact. That's why we focus a lot around our guidance features. We kind of like to think of it as an analyst constantly standing next to you and helping you, pointing you in the right direction, telling you where to look next, right?
The analysis report shows us that BeyondCore looked at 1,884 variable combinations in those few seconds and has presented 6 of the graphs to us. It is suggesting we look at diagnosis, but it's also suggesting we look at age and diagnosis or facility and diagnosis. And if we click this, we can see that the software feels some of these are interesting while others are not. And the ones it doesn't consider interesting, it has grayed out. Let's look at what's happening with Hospital E. Well, what we find is Hospital E is behaving about average for things like congenital heart failure. It's not behaving differently at all. But for acute cerebrovascular disease, it is behaving differently. There is a longer length of stay. For rehabilitation care, it actually has a shorter length of stay. So the software very quickly pointed out to us that we should have looked at hospital E, and it's also pointing out what's important. If I turned off the guidance feature, this is exactly what you would see in any visual analysis software. The visual outlier, septicemia, is completely obvious. But what we want to know is whether hospital E is behaving differently from the norm for septicemia. We want to know the statistically adjusted behavior. To see this, we turn on the guidance feature, and we immediately find that septicemia actually isn't that interesting. In fact, acute cerebrovascular disease is where hospital E behaves differently.
The other thing is there's a few companies like ISD and others that are also trying to use machine learning for predictive analytics. The key difference between us and them and most of these companies, we have made it incredibly simple. We talk about bringing the power of machine learning with the simplicity of a Tableau or a visual analysis, right? Any user can click a button, just one button, and they're done with the analysis, and the software walks them through it. Most of these other products are designed for data scientists. They get you part of the way, but then you still have to hunt through the needle in the haystack. In fact, it's a needle in the middle of the Amazon, right? Mm-hmm. Helping you get part of the way doesn't help you. What we have done is solve the complete problem. Go from the beginning of the analysis to that animated briefing, walking me through the key insights and explaining why each of those key insights are interesting. So we have solved the whole problem, not just part of the way.
And it seems that by combining different types of analysis, you've cut through some of that complexity.
Absolutely, because it's irrelevant. A business user shouldn't have to understand what's the difference between data warehousing and machine learning and regression analysis and statistics. Why? Why do they care, right? What they care about is, I want to know why my patient length of stay is behaving in a strange way. Tell me what diagnosis I should focus on. Tell me what hospitals I should focus on. Tell me if payment, for example, matters. That shouldn't happen. Well, I want to find out in which hospital does the payment type matter, because I want to dig into that. Get me the business insights, take all the mechanics out of the way. This is the difference between an iPad and the old style computer kits where you had to assemble your own PC. It's very macho to be able to assemble your own PC. And I used to be one of those guys, right? I made my own PCs, but I like my iPad now. I want that simplicity. I want you to solve my problem for me, not create more problems for me. That's the difference between a solution and a toolkit.
Now, you obtained the data for this particular video from public sources. Are there some extra types of data that you would like to have collected so that it was out there in the public to use?
So there's always more data that we would like to see. But what happens is today people get into this collection mode where they're trying to collect as much data as they can, but they don't know what they're going to do with it. It's like putting a lot of junk in the attic, right? Mm-hmm. What you want to do is do quick analysis, find out interesting patterns, and then say, why is this happening? Like we had a funny situation in one of the analysis where for a certain famous city in the US, we were finding very interesting patterns for heart failure. And one of the physicians involved in the project said, this city has a very rich population, a very poor population. Is that what's driving this, right? The salary information, the income level was not included in the data set. But once you found the problem, it's very easy to go in and say, I want to collect that information too, because we think that information will have value. Doing undirected collection of lots of information and putting it in Hadoop clusters where you don't know what you're going to do with it is not very useful. Doing this kind of incremental improvement is.
It's incremental, as you say. It's iterative. You find out what you can and then try again with new data.
Exactly. And you keep incrementing it and you're not wasting effort. You're getting to business insights that are useful today, and then you can make the insights even richer tomorrow as you add more data.
So try to speculate a bit. Where will the healthcare field be in 5 years? What can data do to change what people are doing?
So fundamentally, I feel that today we are in a kind of an ivory tower phase of analytics. Power is in the hands of a few people that have powerful machines and that have the right degrees, and they can go and do these magical things called analysis. Technology has impact when my 13-year-old niece can use it. Technology has to become that simple. And that's what I think is the next phase. Let's say I'm going for elective procedure. Today, there is no way for me to know what hospital should I go to. What hospital has the best record for my background of patient? I would like to be able to plug in and say, okay, here are my characteristics. I'm going for an appendicitis. Which is the hospital which has the best outcome? right? Give the power all the way back to the patient. Empower them with true information. Or I'm choosing between medication. I want to know that this medication is better for me precisely because I'm Asian, because I'm middle-aged, because I've had this pre-existing condition, I should take this medication. Nobody has that level of data today. At least they're not exposing that level of data in a manner a business user can use or a patient can use.
Want to predict how long you'd be staying if you went to a specific hospital for a specific disease? Let's say your age is 56 to 64 years old, and your diagnosis, the disease that you're trying to get treatment for, is septicemia. Now, you want to consider any hospital near you, but let's forget about all of the other variables. And we get certain interesting drivers, like Hospital C has a significant increase in length of stay if you have septicemia. In general, septicemia has a very high length of stay. But what you're really wondering is, which hospital should I go to? So let's click on compare, and I can immediately see that if I go to Hospital C, I'm expected to stay 10 days more than what CMS would suggest. And if I go to Hospital J, I'm only going to stay about 2 days longer than CMS would suggest. So that quickly gives me a sense of what decision I should take. Predictive analytics is useful by itself, but when you can make it simple so that people can take data-driven decisions very quickly, that can be far more powerful.
So we're moving not only from data analysts to clinicians and giving clinicians tools, we're also moving to patients and giving them tools.
Absolutely. We call it advanced analytics for all. The goal here is to take analytics from being this ivory tower, which will never have the true impact, and putting analytics into, it's almost going to be like Google, right? Just like when you think of a question nowadays, you go in and you search for Google first. Make analytics that simple. You don't have to think about it. You don't have to provision for it. You have a question, well, go check that question out. That is the future of analysis, where it's as ubiquitous as Google.
Wow, thank you, Arijit. This was
really appreciate it. Thank you so much.
Very interesting conversation.